Good morning, AP Calculus. We are back. I wanted to give you one more example regarding the first derivative test. The reason being is that the first couple of examples I gave you, we only looked for critical numbers where the first derivative was equal to 0 because the first derivative was always continuous. I did want to talk about an example because I know there was on the sheet in which the critical numbers are coming not only from when the first derivative is equal to 0, but also where the first derivative does not exist. So let's go ahead with this example here. We have f of x is equal to the rational function 2x squared over x squared minus 9. And our task is to find on which interval or intervals, if any, is f decreasing. Okay, so we know that a function decreases when the function's first derivative is, when the function's first derivative is negative. So we got to figure out when this function's first derivative is negative. We're going to do the first derivative test to help us out in that regard. So let's get the first derivative. Now we see ourselves, we have a quotient here, so obviously we have to do the quotient rule. So that gives us f prime of x, all right? So we know, here's our fraction bar, and we have bottom, wrapped in parentheses, derivative of the top, which is 4x, minus, now we keep the top, 2x squared, and derive the denominator, which is 2x, all over the denominator squared. All right, bottom to top minus top to bottom, all over bottom squared. There is our first derivative. Okay, now we need to find the critical numbers. The critical numbers occur when the first derivative is equal to 0 or does not exist. Okay, now we have ourselves a rational expression. It hasn't been simplified yet, and we'll get to that in a second. A rational expression is equal to 0, or general, a fraction equals 0, when the numerator is equal to 0. So this first derivative will be equal to 0 whenever the numerator is equal to 0. So let's take a look at that numerator. And I'm just looking at the numerator only. So we've got, would you agree we could distribute the 4x? Giving us 4x cubed minus 36x. And then over here we have negative 2x squared times 2x. That's going to be minus 4x cubed. We're interested when that is equal to 0. And obviously the 4x cubes are out of here. So negative 36x is equal to 0. What value of x makes that statement true? Exactly, x must be 0, okay? So that is one critical number. But it's not the only critical number because we also need to check out when the derivative, or the first derivative, does not exist. Now, a rational expression does not exist when the denominator is equal to 0 because we know that we're not allowed to divide by 0. So if the denominator is equal to 0, then we're talking about something that does not exist. All right, so we need to figure out when x squared minus 9, quantity squared, is equal to 0. Probably do that in your head. We see a little dots there, x minus 3, x plus 3. So we know that x squared minus 9 squared will equal 0 when x is negative 3 or positive 3. So we have three critical numbers here, negative 3, 0, and 3, and we have to put all three of them on our number line. All right, so that's our next step. Once we get our first derivative and our critical numbers, we place them on the number line. So we have 0 here, we have 3 there, we have negative 3 right there. We have to pick some test values. Now there's 3 intervals, which means we have to pick 4 test values. Something to the left of negative 3, so let's just say negative 5, all right, over there. Negative 1 is between negative 3 and 0, 1 is between 0 and 3, and 5 is greater than 3. So we're going to take those 4 values, and we're going to plug them into the first derivative. Now, I've got a mess over here, but ultimately, I've got negative 36x over x squared minus 9 squared. Now, the denominator is being squared. So what does that tell us about the denominator in terms of it being positive or negative? Exactly. The denominator is always going to be positive because you square something, you get a positive value. So no matter what we plug in, whether it's negative 5, negative 1, 1, or 5, the denominator is always going to produce a positive result. The question is what happens in the numerator, okay? Well, if our first test value is negative 5, so let's plug negative 5 in for x. We have negative 36 times negative 5, and negative times a negative is a positive, so when negative 5 produces a positive numerator. And a positive divided by a positive is a positive, so we know that that will be positive right there on our sign chart. Now we go to negative 1. Would you agree it's going to be the same result? Okay, negative 36 times negative 1 is a positive value. Negative times a negative is a positive. Positive divided by positive is also a positive. So we are increasing as well from -3 to 0. Okay? Now we go to 1. Well, if we plug in 1 for x, we have -36 times 1. Pretty sure that that's a negative value. Denominator is still positive. Negative divided by a positive, that would be a negative. And the same thing's going to happen with 5. -36 times 5 is a negative value. Divided by a positive gives us a negative value. So we can see from our plus-minus chart that we have a function which is increasing and then increasing again, and decreasing and then decreasing again. And while the sign does not change from 0 onward, the issue is really at this 3 right here. The question really becomes, can we say that our interval is from 0 to infinity? Okay, if that's the value in which our function is decreasing. All right, because again, we know a function is decreasing when the derivative is negative. And unfortunately, this would not be a correct answer. And the reason being is that this says that the function is decreasing when x is equal to 3. Okay, but if we go back to our original function and you plug 3 in for x, we get a value that does not exist. The function doesn't exist at 3. So how can it be decreasing at 3 if it doesn't exist at 3? So this is actually an incorrect answer. That was a pretty bad job of crossing that out. Let's try that again. There we go. All right, if we're looking for when the function is decreasing, we would need to say between 0 and 3, and also from 3 to infinity. Okay, and again, we're always giving a reason, and the reason would be because f prime is negative on these intervals. And once we have that reason down, along with our 2 intervals, we are good to go. So hopefully this helps out with those problems in which you have to do some kind of rational expression, some quotient rule or maybe a chain rule that results in a denominator. I'm thinking something like the square root ones. You do need to check both when the numerator is equal to 0 and when the denominator is equal to 0 if you've got some kind of rational expression for your derivative.